Thank you all for coming. My name is Maura McAndrews. I'm the Director of Research Administration here at the School of Public Health. Amy Confair is also a member of our office. She's not here today. And then we have Craig Newshafer, who's our Associate Dean for Research. So, and together we make up the Office for Research at the School of Public Health. So for today's workshop, we invited a group of Drexel experts to provide an overview of the different facilities, resources, and support available to our related to research data storage and security. There's been a tremendous amount of interest on these topics here at our school, and I'm sure more people will file in, which is great. But we are capturing the presentation, and we'll make sure that our faculty have this as a resource. So not only will the presentation be captured, but we'll be taking notes, and we'll have the slides available on our website. So we're very appreciative of our speakers to come out today. I'd like to just introduce everyone at one time. We have Larry Wynn, who is our School of Public Health Network and Systems Administrator, who's our go-to guy for most IT matters. Paul Keenan joins us from IT. He's the Executive Director of Systems and Security. Lauren May, in the back there. She's the Director of Research Program Development at the Drexel College of Medicine. David Chin here is the Senior Systems Administrator for the University Research and Computing Facility. And finally, last but not least, we have Deborah Morley. She's the Director of Data and Digital Stewardship at Drexel Libraries, and Kathleen Turner, who most of you know already. She's a wonderful resource for our school, and she's the liaison librarian over at the library for our school. I'll turn it over to Larry.
Good morning, everyone. I'm Larry Wynn, the System Administrator for School of Public Health. I'm just going to be going over some basic stuff, some computing needs, network needs, and security. And Paul and David will go into more details in their areas. So here are some of the main topics I'll be talking about. I get a lot of questions from faculty and staff about what kind of computers to get for their needs. So I'll go through all the different options that we have, and then we'll talk about storage. Again, different options we have for local network and cloud storage and backups. And lastly, we'll talk about a little bit about security. I'll be HIPAA compliant. So here from bottom up, we have the lowest level. Virtual desktop, essentially, we've been using it for class use. The reason we implemented virtual desktop is that a lot of students require special software in their classes. In the past, they've had to buy their own software for the 3 months that they're using. So as last year, we decided to implement this virtual desktop, and it's been being managed by the College of Engineering. So I believe we purchased the hardware, and they're managing our system. So we basically have a maximum 100 seats. So you have a maximum 100 simultaneous logins. And the good thing with virtual desktop is that all you need is a browser. It works on a cross-platform, Mac or PC, and all the computation is done on the server side. So it doesn't matter what kind of spec on your computer. You can run it fairly well as long as you have a pretty good network connection. And next up is standard desktops. So these are our standard Optiplex desktops or Latitude laptops. And these are great for just everyday office app, and you could even run data analysis on some of the higher end stuff. Of course, there's always some overlap between the different tiers. And then once we go above and we have the workstation, these are the Dell Precision workstations. I've been getting a lot of interest, especially people working with large data sets. So they need a large amount of RAM, and multi-processors. So when you go into the workstation, precision workstation class, then you have option getting basically a dual processor with multi-core Xenon processors. And then you could have up to, I think, 3 terabytes of RAM if you have the money for it. And then next up is the servers. So we don't really have any, I don't think we have too many servers here. I think Brian Lee he's running his own Linux server somewhere in the closet. And I know Paul has supported some of our Calypso, which is a clinical recording system server over in Corman. But there's a lot of similarities between workstation servers. Servers typically, they come in, kind of rack mounted system, but they share a lot of the same hardware. And but the downside of servers is that they're extremely loud and they output tremendous amount of heat. So it's not something you want to have it sitting next to you or in your lab. In my old days, I used to build servers for Autism Research Group, and we literally had 2 of these things sitting in our small space, and it was just in the summertime it was just incredibly hot. The AC couldn't compensate for the amount of heat it output. And oftentimes servers, because of the heat output, it require dedicated cooling. So if you kept in your enclosed office, you run into overheating issues and you shorten the lifespan of the server. And then the very top is cluster computing. That's basically a combination of many servers connected, and David Chen will talk about that. So I'll go into a little more detail. So again, VDI, low system requirement. The end user doesn't have to install any software. It's great for student use, but it's not typically something you want to use for a major data analysis. Standard desktop runs 15,000, 2,000. Typically comes with the Intel i3 to i7 most of them are dual quad core processors, and you have option between 4 to 6 gigabytes of RAM. And typically, this is our standard system for our staff and faculty. And it's great for running Office apps and medium data sets. So you could run SAS comfortably on here. ArcGIS, not so much. And R and Stato also will run fine on here. And then next here is the workstation. That's a huge price range. You can go way up to over 150,000 if you wanted to. But typically systems, the higher end, you can get 2 dual processor, and each processor, the highest has a maximum of 28 cores. And then again, the RAM, you can go all the way up to 3 terabytes of error correction RAM. And with the workstation, you have more space for hard drives, so you have the RAID options, so you could do redundancy. You can mirror your hard drive. So if one failed, you basically have exact replica of your primary hard drive, and so there will be no downtime. And then you can have other forms of redundancy. So this is great for research data, for working with large data sets. Since the system has such a wide range in pricing, you could cover it and any of your computing needs. I know we've, for ArcGIS in particular, we found that with ArcGIS Pro, that's built on the higher, a 64-bit platform compared to ArcGIS Desktop that's still built on an old 32-bit platform. We see a significant performance gain with the Dell Precision systems. I know most people are still using ArcGIS Desktop, but I think we're kind of promoting ArcGIS Pro because of the very reason. And next, we have servers. Again, there's a lot of overlap between workstation and servers. Servers, you could have similar, basically the same type of processor. You can fit more memory and more hard drive. So these are great for multi-user. So if you have a lab with multiple users, they all can log in at the same time. But oftentimes they're running Linux in the background. And finally, cluster computing, you could, that's sky's the limit basically. And I think China currently has the fastest supercomputer that costs $73 million, and it's just incredible computing power. So I'm going to talk a little bit because a lot of people ask me, like, can I get my computer image? But they have no idea what that means. Now that I've been trained by RT to do the imaging for our computers, I just thought, kind of introduce what it entails. So basically, when you get a new computer, each computer has a MAC address. It's part of their network ID. So I would register the computer name, the MAC address, and then SCCM is basically a deployment tool. So we create a Windows 10 image with all of our standard software as part of the task sequence. So once we get the computer on the network, we put in the flash drive to kick off the task sequence. Basically, once it's plugged in, I just leave it alone, and it goes through the entire task sequence. And part of that is installing Windows 10, and then joining the domain, and installs all the software packages, Office, and whatever else that I can choose to add other software to that package as well. And lastly, install Sophos antivirus and safeguard encryption as the last step. And then after that's done, then I basically will install additional software. People need SAS or ArcGIS, Stata, software like that. And then I would deploy it to the end user, and then help them map to department printers and network drives. So typically, in my experience, imaging takes about an hour and a half, depending on the speed of your hard drive. But it's a relatively painless process. And one reason they handed this over to me is we had, like I said, we had a lot of interest in precision workstations. That's not one of the IRT standard system. But I found that their standard image worked pretty flawlessly on the precision workstation too. I haven't need to do any modifications or install any additional drivers. It just imaged like any other system. So it's worked out pretty well. All right, so now move on to storage. So there are different types of storage. You have the local hard drive, and you have the removable hard drive. Then you have the network drive, and then cloud storage. So the things in green are things that, since all Drexel computers need to be encrypted, so when you get your computer, doesn't matter what type of hard drive, you can have hard disk, which is a traditional spindle hard drive, or the newer solid state hard drive. They always come encrypted before we deploy to the end user. And of course, safeguard encrypted shared drive, that's also HIPAA compliant, and OneDrive is HIPAA compliant as well. Now, there's a little gray area with the removable hard drives. If you buy removable hard drives, there are FIPS 140-2 certification, which is like a HIPAA compliance certification hard drive out there. And there are also FIPS 140-2 compliant flash drives. They're a lot more expensive. I mean, we're talking about $150 for a 16 gig. They might have come down a bit now. But those are HIPAA compliant. But most hard drives, external hard drives and flash drives aren't. But with help with Tim Chamberlain over at security, we're able to encrypt external hard drives as well. But the downside, I think it has to be connected, obviously, to encrypted Drexel computer and enable unlock the data that's on the hard drive. You couldn't just bring it home and connect it to your home computer because you don't have the encryption key. And the things are absolutely no for PHI is unencrypted department of network drives and Dropbox. I know a lot of people are still using Dropbox, and they're very resistant to switch over or migrate over to OneDrive. So OneDrive HIPAA compliant works just like Dropbox, and safeguard encryption drives can only be accessed from Drexel encrypted drive. Okay. So this is kind of the workflow of new shared drive requests. So typically you have to decide, what folder you need and where to put it. And so for the School of Public Health, we have an unencrypted drive, which is under department's SOPH. And then we also have encrypted share that's under Drexel/encrypted. And then there's a separate SOPH/EOH. So as of now, people used to send requests to IRT directly. But over the summer, I guess, they're understaffed, people on vacation. There was an issue of, a long delay. So we decided that for everybody just to send the request to me, and since I know who to contact within IRT, if there's a lengthy delay to get these going. So basically, everybody submits a request to me, and I triage, and I'll send it either to accounts or to InfoSec for encrypted drive share requests.
Sorry, is there some kind of standard as to what the target is for getting the request processed from IRT?
Time-wise?
Yeah, there's an expectation that 2 weeks.
It really varies. I mean, I have times where they've gone to requests within the day. And then over the summer,
I can answer it because my group. Yeah. So we try to do it within 2 weeks. As Larry said, we pretty short staffed and we've lost people, and so it's been a challenge sometimes. So we don't always meet that, but that's what we're shooting for.
Okay. So since I submitted a ticket, I would get a confirmation when the ticket is completed, and then I would help map the end user to the shared drive folder. So that's typically how it goes. And, all right, so let's move on to local hard drive options. So when people are looking at systems, they often ask me, like, what's the difference between a SATA hard drive and SSD? And here's some of the breakdown of pros and cons. Obviously, the solid state hard drive is a lot more expensive, but the price has come down quite a bit. I think for most users, I would definitely recommend SSD. It's significantly faster than the conventional hard drive. So SSD is faster, it's more durable. Only downside is capacity. And if you need terabytes and terabytes of hard drive, it can get costly. One of the workstations over Office of the Institute, we have, I don't know, eight terabytes or more of SSD, and that's running to thousands of dollars. I mean, it's close to the cost of the system itself. But if you have the means that would definitely be the way to go. And since SSD doesn't have any moving parts, it doesn't create any noise, and there's lower power consumption as well. But what's most important is both of them. If you're storing data on your local hard drive, you have to think about backup. And what is going through the school verifying HIPAA compliance with safeguard, it's surprising me how many people weren't backing up their stuff, or they had no idea they needed backup stuff. So they had their mission critical data just sitting on their local hard drive. Crash plans only was at $6.90-something per month. What's that? Oh, okay. So it's affordable. If you choose to store locally, that's what you should be doing. External USB hard drive, like I said before, FIPS 142, 140-2, and then there's password protected hard drives, but they're not necessarily HIPAA compliant. There's unprotected. Typically, external hard drives are not protected at all, but you can encrypt it using SOFOs to meet compliance. And here at network storage, we have unencrypted, so you can store non-PHI, and you can store PHI unencrypted. The big difference is unencrypted, you can access from home computers on your VPN into the Drexel network. But for an encrypted drive, you absolutely have to use a Drexel encrypted computer in order to access the encrypted drive. And typically when you sign, you get a 2 gigabyte quota, but you could always ask for an increase. And if you need more than 2 gigabytes, you could provide justification. They usually are very easy to work, and they'll provide you more if needed. And user ID is required, and backup. Everything stored on the network is backed up on a regular basis. But I think, Paul, correct me if I'm wrong, it only goes back about 90 days, right? You can't retrieve.
Depends on what it is. Sometimes it's 30 days.
Okay.
So, but typically not more than that.
Okay. So cloud storage, and this is just comparison between what we're trying to promote, Microsoft OneDrive versus Dropbox. Microsoft OneDrive is considered HIPAA compliant, so you can store PHI, and you're provided 5 terabytes of cloud storage, which is a huge amount data storage. Block level file transfer refers to when you make changes to a file, it doesn't have to upload the entire file. It can upload only the changes you've made, so it makes a file transfer faster. And OneDrive encryption is also a REST, but that's for business accounts. If people are using the standard personal OneDrive, just be aware that your data isn't actually encrypted at rest.
All right, you can cover this, or maybe somebody else is covering this. But, an issue with OneDrive is so great that it's HIPAA compliant, but a lot of times when you compare data security plans, you need the actual technical language around this to cut and paste.
I have a link in one of my slides.
And then versioning refers to go back and retrieve previous data if something got corrupted or deleted by accident. And then it's a little brief blurb about liquid files. There are some people that need to transfer or share encrypted data with outside collaborators who may not have OneDrive. Liquid files work quite well. I don't think is it advertised on. I mean, most people don't know about it. That's
so yeah, that's gonna add a little bit of
okay.
So we have a limited number of licenses.
Oh, okay.
But we have plenty. So I mean, we're not nowhere near our capacity. But requests for liquid files need to go through the Office of Privacy and Compliance.
Right.
So I can't just set you up for liquid files. I have to get a request from Robert Asante that says that I've authorized this person. And basically, it gives him a chance to talk to you about who you're transferring the files to and make you aware of kind of the risks and all of that. I don't think he's ever said no.
Yeah, I don't think
just, it's just kind of a chance for him to talk to you, I think.
And that's it. All right. Any questions?
So the OneDrive versus Dropbox, is there a reason why we would want to continue using Dropbox when there's OneDrive?
No.
No, the short answer is no. I mean, we're really trying to push OneDrive because it's HIPAA compliant. Some people say, well, I don't work with PHI, so why can't I use,
There's other reasons for it too. So consider this, say you have a postdoc working for you, they're storing all their stuff in Dropbox, and they leave, or worst case, they die. The data is unavailable to you. Drexel has no way to say to Dropbox, give me this data, it's Drexel data. They say, no, it's a personal account, I can give you that. And that's gone. Like, you can't do anything with that. The relationship we have with OneDrive is a business relationship where Drexel administers OneDrive. And so in that case, you say, oh, this person worked for me, and we validate that, oh yeah, you're entitled to the data, and then you just move the context to your control. So there's a huge sort of practical advantage as well as the security advantage.
So if I store data sets on OneDrive, I want to analyze them. Are they accessible for my statistical software?
yes, they are.
Yeah, so things that are OneDrive, this is going to be changing shortly, but you will be able to have some things in OneDrive that you don't store locally. But typically, things are stored locally and on OneDrive. So when you're doing the analysis, you're actually doing the analysis locally.
And then what's the benefit of putting data on OneDrive versus the SOPH encrypted?
So the advantage,
Well, the big advantage, I think, is that you manage the data. Whereas on the network share, you always have to request, make a IRT request to accounts for other users' access.
But it feels like if we use it on OneDrive, then everyone who uses it will have a copy of it locally then. And that might not be as secure as if everyone points to that SOPH.
There's your personal OneDrive account, right? And then there's also a shared one.
Right, that's what I mean. If I'm sharing it with everyone who should have access, it seems like you can control other access, like
so
SOPH we can have.
you're totally right that when you share with OneDrive and as people get it, they get a copy of it and they can continue to have it on their local system.
Well, that's no different than network drive. I I mean, once you give a user access and they're mapped to it, they can offload that data too.
But
So
it doesn't,
But if
by
it's
default.
encrypted, you can make sure that they're using it basically on it.
right,
Device
yes,
that
yeah.
has
The only
it
difference is
installed.
encryption. Yeah.
And we can control read access on SOPH, right? We can give people read-only access.
Same with OneDrive, you can
Yeah.
restrict.
Yeah, you can control their access. What is coming, that I will tell you, but we have a license for it, but we haven't deployed it yet. It's pretty complicated. But there's a Microsoft classification tool called Advanced Information Protection, and you'll have much greater degree of control over. You'll be able to click on the file and basically say, this person can read it, they can't print it, they can't share it with somebody else. They can have it for 30 days, and then after that, they can't use it anymore. So that's coming. We're not quite there yet.
So if they can read it, are they automatically downloaded?
It's downloaded, but it's encrypted. And so basically, they have an encryption piece that's associated with their use, and that piece governs how they use it. So there's basically it embeds information in the file. Now there are limitations to this technology, mainly that it's office related. So if it's a data set that you're sharing, not going to work.
Isn't another big difference the OneDrive is actually sharing from your personal or your individual account versus a shared space?
That's true.
Right.
That's true. So it's
So it's
coming from
coming
your,
out of your 5 terabyte.
it's coming out of your 5 terabytes. So typically 5 terabytes is pretty good.
You can access OneDrive from any computer, it doesn't have to be addressed or.
That's correct.
Right.
So, Larry, the sheet that you had where it's kind of like a schematic for once a computer is imaged,
Yeah.
and then does the encryption, and then you go on to do the different program, like any other programs, like everything are.
Right.
So if your computer was not encrypted, and you have already that software that you have down there, say it's a list of like 10 different things, you have to re-image?
No, I mean, you can install Social Safeguard after deployment as well.
In fact, you actually have to. But essentially, it's sort of like it has to be the last step of the deployment after the operating system's already there.
Yeah, only thing we don't encrypt is like student computers in the lab,
Okay.
shared computers like that. But most staff faculty must be encrypted.
Okay, I think we should move on and welcome Paul up to, we'll have time for more questions, but we want to make sure everyone has their time.
And feel free to interrupt me as I'm talking, or if you're, I'll go through anything that we have the Larry's already covered quickly if I can. So a lot of the feeling is like, why are we involved? And the answer to this, you're a self-selected group, so you probably already believe that you have a responsibility for security. But a lot of times people don't think that they have a responsibility. That basically, oh, Drexel's got a firewall, or Drexel's got, permissions on file servers, and that's enough to protect you. And the truth is that we do try and do all of those things, but the way data is most often compromised or lost, considering a breach, is because an individual did something inadvertently or was fooled into doing something bad. So most of the time, when something's lost and data's lost, it's somebody's lost a desktop, somebody's lost a laptop, somebody inadvertently sent a file that they shouldn't have, or they sent it to a person that they didn't mean to send it to. That's where things happen. And so a lot of times people think, I'm not really dealing with secure data. Everything that I deal with it's just research data. There's no personal data. Most of us have access to information, even if it's only our own information that's pretty sensitive. And so those are the kinds of things that you want to be aware of. So obviously, it's easy to think it doesn't really apply to me, and I don't have to worry about all of these security precautions. The reality is everybody's kind of got to face this. So this is, this is the reality. When I started in this business, the internet was new. It was devised by researchers for researchers. Open communication was what it was all about, easily transmitting data. It's still at its core that way, which is great and terrible. So it's great because it makes a lot of things really easy to do, and it makes it really easy to move a lot of data around really quickly. What it's terrible is it also makes compromising that data really easy. And everything that we have done since the beginning of the internet has been sort of bolting on security because it's not really designed with security in mind. Initially, we had to worry about people maliciously defacing sites, kids just sort of testing their acumen at hacking computers. The concerns were much more controllable and more easy to deal with initially. It's a totally different world now. We're not really talking about, This is the reality now. Sorry, the red didn't show very well, but basically what this is saying is it's now more profitable than the drug trade, cybercrime, that it's evolved from ad hoc individuals to a network of highly organized groups, often connected with traditional crime groups, drug cartels, mafias, terrorist cells, and nation states. This is the new reality. And I mean, it's not going to get any better. It's going to get worse. So this estimate at the top of $6 trillion, I can tell you right now that that's all, that in 2021, they're saying $6 trillion is what it will cost. And so that's both the amount that it will cost companies in terms of the loss of data and intellectual property and everything else, but also the losses caused by remediating all of that. But it's also about individuals, because the Internet of Things is what's going to drive the $6 trillion. So all of these things that now talk to the internet, whether it's your TV, your baby monitor, your doorbell, your everything that talks to the internet now, security is the last thing that is considered in all of those devices, because it would impact the cost of them. They're trying to keep them cheap, so security is never considered in what they're doing. And I think that's starting to change. But right now, a lot of what you've heard about with really big attacks where people lost access for a day to all the major sites, Google and Amazon and everything else, that was an attack on basically the root DNS servers for the internet. And that attack came from, internet home routers, baby monitors, all kinds of things like that. It's just going to get worse.
Now, Paul, with the introduction of Office 365, I think I've noticed a lot more phishing attempts.
Yes.
That's based on your 365 account. Right?
So I would say what's happening more is we've seen a huge increase in the number of accounts that have been successfully compromised. They're almost all students, which is much better from our perspective than staff accounts who have access to a lot more data. But not great, because what happens is you're getting messages that appear to come from a legitimate Drexel address, because they are coming from a legitimate Drexel address. It's just not a Drexel user sending them anymore. And so they're sending you something, it has malware in it, it has links to bad sites, and people are more likely to click on those links because it's coming from Drexel, and that just perpetuates the problems. So we literally went from maybe seeing 30 accounts compromised a month to, in its height in August, over 650. And we're working as much as possible to get that under control. We're working with Microsoft, and we have reduced it by about half, but it's still really, really bad. What I think is better is more things are being correctly identified as junk mail, as spam with O365. So things are going right to junk mail instead of you having to sort of sort through them as much. But that's sort of a hollow victory. But there are things that we have in place that make it a little bit better. We have something called advanced threat protection in Office 365, which I'll talk about a little bit later. But it helps, but it's not helping enough, and we're well aware of that. And this is one area where it is our job to be doing the protection, and we're not doing as well as we could be. Hopefully, we'll get better. So I'm going to talk really quickly about some of the common threats that we see regularly. So you probably all heard of ransomware. Basically, ransomware is somebody gets an email, they click on it, it downloads software on their machine, and then it's silently, you don't see it happening, it starts encrypting all the files on their machine. It encrypts all the files that they have access to on file servers. And at the end of that process, it basically locks those files and puts up a screen that says, we now hold all of your files, send $300 in Bitcoin to this address, and we'll send you the encryption key. And generally speaking, there's no recourse to that except restoring from backup or paying the ransom. Paying the ransom is not recommended. I know of a researcher here who's done that because she did not have any backups. But number one, while they tend to actually be fairly good about providing the encryption key, it is not guaranteed, and you also don't know that they are not doing anything else with that data. So you're better off dealing with backups. And so that's what, Larry mentioned Crash Plan. I would strongly urge any of you who are not using Crash Plan to use it. OneDrive, some people think, well, I have all my files synced to OneDrive or Dropbox, and that'll protect me. Not really. So while OneDrive does have versioning, the ransomware makers have gotten smarter. And so what they do now is there's only a certain number of versions that OneDrive will keep, or Dropbox, or anybody really, any of these synced files. So they'll just write the file over and over again. And so all of the files will be encrypted that are synced. And so it's not really the same kind of protection that you would get with Crash Plan.
Oh, sorry.
Sure.
So is Crash Plan not required?
Crash Plan is not required because we basically charge departments for it. I argued as strenuously as I could that it should be part of the encryption program, that everybody who got an encrypted computer got Crash Plan. I lost the argument.
No, as needed in cases. But I've been promoting using network drives and stuff, so most people, that I've worked with tend to store all their stuff on the network drive. But again, like Paul said, Crash Plan is, the best solution for backing up.
Yeah, if you have anything stored on your computer that you care about, I really think you should be using Crash Plan. If you're horrified at the notion of somebody coming in and saying, I need to reimage your machine right now, you probably need to install Crash Plan because that's what it's protecting you against. Phishing, this is what Larry and I were mentioning earlier. This is extremely common. They vary in how effective they are or how good they look. basically, if anybody sends you a message with multiple exclamation points in it, be suspicious. You'd be surprised. I can't use that as a rule because a lot of people do send legitimate mail with 4 exclamation points for some reason. But phishing is great for that. They want to incite a sense of urgency in you. You're going to lose access to your email. You're going to lose access to your iTunes account. You're going to lose access to something. They're trying to get you to click because they're trying to generate a sense of fear. They're trying to generate some sense of urgency, typically. Be wary. And as we said, the number of phishing attempts have been increased. And just because it comes from a Drexel address, do not assume that it's legitimate. You know what the messages from IT look like. If it doesn't look like that, it's probably not from IT, even though it says IT help desk at the bottom.
Now, does Sophos antivirus have any sort of malware protection, or is that purely?
Sophos antivirus does have malware protection. It is, I think, like almost all endpoint antivirus at this point, moderately useful. So it detects maybe 50% of the malware, and the reason for that is that it's just malware is changing so quickly, so fast, and the number of variants is out there is just unbelievable in hundreds of thousands to millions per day of changes. So it is a losing battle for the malware companies. We are about to deploy a new type of malware protection that's more based on the behavior of what we're seeing from the machine. So if it looks like it's trying to talk to a command and control server, it uses real-time threat intelligence to update it. So we're hoping that that will help, where we'll be able to stop this stuff in a different way. But yeah, Sophos is, it's as good as any of the other sort of traditional antivirus solutions, but it's not totally useful, so you can't depend on it.
So somebody's computer can be compromised. They wouldn't necessarily know it.
You would not necessarily know it. Typically, the way people find out their computer is compromised is because somebody from my group identifies it and takes them off the network. They call the help desk, and the help desk says, "Oh, we took you off the network because your computer's compromised." They had no idea. Sometimes you'll see something like where their mouse is moving without you, or something like that, and then they're like, "Oh, okay." But typically, you won't know. So these examples, the first one has not happened at Drexel because we don't allow you to change your direct deposit information electronically. And while that's possible, I have made it a personal line in the sand that we're not going to allow that. A lot of schools have been affected by this, where people get their accounts compromised and their direct deposit information is changed, and suddenly they don't have a check anymore. And it's really hard to deal with that after the fact. These other ones happen pretty regularly, actually. Spear phishing is just like phishing, except that I say, Craig looks like he has an important job. He probably has some pretty valuable data. So I'm going to send him a targeted email that's targeted to something that I've read about online about his profile. He's interested in this thing. I'm going to send him a phishing message that's targeted just to him and try and get him to click on a link so I can compromise his computer. It doesn't happen as often. It does happen quite a bit. It happens a lot with people in finance offices, where we've seen it frequently here, where they get a message that is supposedly from President Fry that says, "Please do a wire transfer for X amount of dollars." You laugh, but I know schools where the finance department's fallen for that. That's not it has not happened here, but it happens. And these tend to look pretty good usually. So it's more a matter of being aware of, like, would this person really send me this? Drive-by downloads. That's basically when you go to a website or you click on an email that has malware embedded in it. It downloads it to your computer. You don't see it, and suddenly you're infected and potentially compromised. Watering hole attacks. These are very clever. I go to a professional association site, for instance. I'm almost done. I go to a professional association site, and suddenly you're compromised. And it's like, that's a real site. What happened? What happened is somebody said, hey, financial aid directors, they've got a lot of valuable information. I'm gonna go after an association for financial aid directors or for financial aid workers and compromise that website. So, and so once that website's compromised, you go to it, it's a legitimate website, you click on something that seems totally innocuous, you don't see any bad behavior, but what's happening in the background is a file is being downloaded on your machine to compromise your machine. So these are just some of the things that I talked about before. But a lot of this is why we have encryption on all of the computers at Drexel, is because it's to mitigate the risk posed by losing a machine. So these are just some of the things that to be aware of. But I would say never, never, never share your password with anyone. Like that's the one. If you have one takeaway from this screen, that's the one. Anybody who asks you for a password, don't ever give them to it. Don't give it to anybody. The other one I would say is don't use the same password. Don't use your Drexel password anywhere else other than Drexel. So what happens is oftentimes we see people who get compromised at Drexel because they used the same password when they went to, I'll use Netflix as an example. Netflix gets their customer database compromised, and all of a sudden everybody whose password is the same at their work institution has it, and if you use the Drexel email address, they have your user ID typically, and so they have your password too. And so it's just a bad idea. And I would recommend, if you have a lot of passwords, using a password manager. They're not perfect, but they're better than reusing passwords.
And don't write them on sticky notes.
Don't write them on sticky notes. Yeah, good point.
And what's Drexel's password policy? Are they required to change every swap or no?
That's coming. Honestly, that's an area of great debate right now. Auditors love that you change your password frequently. I change mine every 90 days. The truth is, most of the research supports not enforcing that, but rather enforcing very long passwords, so that you use a passphrase instead of changing your password every 90 days or 180 days. But in all likelihood, we will be enforcing some sort of password change and additional password requirements. One of the things that protects you against having your password compromised is something called multi-factor authentication. It's a little bit of a pain, not much of one. Basically, you enter your password and you get a text or a prompt on an application on your phone that says, "Is this really you?" You say yes, or if it's a text, you put in a 6-digit code that says, "Yes, I've received the text." It's just another way of saying, "Yeah, it's really me." So getting your password isn't enough to get your information. That's coming, and I want people to embrace that, because it really is. It protects you more than anything else. It's probably the biggest protection that we could offer. So let's see. Larry already covered most of this, I think, so. This is the link that Craig was asking about. This basically gives you all the information about the compliance for Office 365 and OneDrive. And some of it's HIPAA, but there's so many various regulations that people have to comply with that this is the page where you can go to see all of them. And there are many.
And how far back does OneDrive store the data?
What do you mean?
But how far back in time can you retrieve?
So when someone leaves the university, is that what you're talking about?
Well, if a file got corrupted or you accidentally delete
So
something, can you go
it handles it not by time, but by version number.
version?
I believe it stores 15 versions.
Paul, are there trainings available to learn about the different features of OneDrive?
There are. Mike Shellman's group in IT offers training on this. They just started to. I know they've had one already.
The career path?
It is not in career path, although there's a discussion about whether we can make some things available on career pathways. But no, that was an in-person training.
How did you find out about those additional OneDrive?
It's a good question. If you go to the IT website and look at training, I can't tell you exactly what the link is, but I believe it's on there. So one of the questions is, when do you use OneDrive? When do you use department file shares? So with OneDrive, you're completely responsible for the security, essentially, because it's up to you whether you're sharing information, how you're sharing the information. You can share it via an anonymous link. That's something that we've recently re-enabled because of requests from researchers. But that means that anybody who has that link can get to that file. So you're dependent upon the person you're sending the link to keep it secure. With departmental file shares, you're basically relying on IT working with Larry or someone else in your department to say, okay, these are the only people who should have access to it. The permission changes are highly regulated. The encryption is tighter because even we can't, when you save to the encrypted file share, my team can't see those files. We can see them, but we can't open them because we don't have keys. So it doesn't really get any tighter than that.
I had a question about researchers who are collaborating with colleagues at other institutions.
Mm-hmm.
And one of the concerns that I heard was that when using OneDrive, you can create that ability for those colleagues to access your space, but that account has to be like renewed every 30 days or something. Is that true, or that it kept expiring? And that they thought that the individual just found that very frustrating in the length of a year-long project.
That was true.
Yeah.
We got that complaint.
Yep.
We ran that by our new Chief Information Security Officer, and he said, no, I don't think we need to do that. And so that's no longer true. I'm just mentioning DFAR. It probably doesn't apply to most of the people in here, but it's kind of going to probably be setting the standard because we have some immediate needs for this. So DFAR is a Defense Department requirement now that if you have Defense Department contract, you need to comply with a very strict security program regimen, and Drexel does fall into that category. So we're going to be implementing a lot of controls that don't currently exist on the wider network on people who are doing Defense Department research, but likely that's going to be a template for broader controls across the board. Data classification is coming. The idea being that if we know what is important to protect, we can we can make the more stringent controls around that and not have people have to deal with the most stringent controls for any data, which is sort of where we are now. Next generation firewalls coming very soon. That's going to help us in identifying and remediating threats from an IT perspective. And as I said, we have a new Chief Information Security Officer who's Dr. Pablo Molina, who is really tasked with maturing the Drexel security program and in terms of getting more groups like this together, educating people, developing policies, procedures, developing incident response plans, all of those things that have been a lot more ad hoc than they really should be.
Okay, thanks, Paul. And I'd like to introduce Lauren May now. She's going to talk a little bit about REDCap, which is more of a data collection and storage tool.
Good morning, I'm Lauren May. I'm Director of Research Program Development at the College of Medicine. And I've been involved with REDCap, which is research-related software available to anyone at Drexel, since about 2009 when it was really just an idea here. And I'm thrilled to say that I've had the opportunity to see all of the growth with the application itself, but also its usage at Drexel, and that's been really exciting. So what is REDCap? REDCap stands for Research Electronic Data Capture, and it's a web-based application that allows you to create and manage both databases and surveys in a HIPAA-compliant environment. Just a quick show of hands, is anyone actually using REDCap or has used it in the past? Okay, great. So I can tone down my aggressive sales pitch just a little bit. It's, as I mentioned, it's available to anyone at Drexel and it's free of charge. So REDCap uses a consortium model, meaning that it was originally developed for and by Vanderbilt, but it's been expanded to include at the moment more than 2,500 member institutions. The beauty of this model is that when member institutions say that they want changes to be made to the application and that they're willing to contribute to seeing those changes through, they happen. So we've seen multiple language translations for REDCap, the development of an offline instance, a mobile application, all of that came about through the consortium. If you take a look at the map, you can see that we are certainly not alone in our use of REDCap. We got in at around the 120 mark, so we've been in for a while to see a lot of good things. Another benefit of being part of the consortium is leveraging the knowledge and expertise of the other consortium members. So just because you come to the REDCap team with an idea that maybe no one at Drexel has done before, we can reach out to the consortium and see if someone has done something similar before and get tips and tricks for the best way to approach your project. So while at Drexel we're encouraging the use of REDCap for studies that involve protected health information, its use really does span many areas. It's actually my go-to application for lots of operational tracking and surveys and things like that. But we use it very heavily at the medical school for clinical research. So why REDCap? I know we have some other tools available at the institution. I just wanted to highlight some of the unique aspects of REDCap. So as I mentioned before, that consortium is huge. You can generate surveys and databases. So we do have tools here that are HIPAA compliant that allow for survey generation. This gives you that database piece as well. REDCap lets you work with multiple sites. So if you had collaborators at Jefferson and Temple and Drexel was the PI site, you could grant access to your study team members at Temple and Jefferson to work within the same project. REDCap is a shared library of more than 1,100 health-related instruments. If you generally use standardized tools, you can pop these right into your REDCap project. You don't need to create them from scratch. And participant scheduling, the de-identification, and the data quality module are all unique, and I'm going to talk about those in a little bit more detail in a moment. So once you're within a project, this left side menu is generally going to look the same each time. And I'm going to quickly go through some of the highlights of the applications here. So this first one is the calendar. This allows you to schedule your participants' visits. So in this case, on February 4th, participant number 1 is coming in for follow-up visit number 1. And I know that I have to complete 3 specific data collection instruments during that visit. So if I click on that visit, those 3 instruments are going to pop up, links to each of them. It's a great way to ensure that you're not missing data collection at specific times. I should say automated data import. The data import tool, if you already have a beautiful database in Excel or an XML file, you can work with the REDCap team to import it into REDCap. You do not have to start from scratch. We have a lot of expertise in the importing area. Automated data export, with the click of a button, you can export your REDCap database to Excel and any of the common statistical packages listed here. This was probably the greatest selling point to Ed Longazel and the compliance team when we were trying to bring REDCap on board. As you're creating your database, every time you're creating a field, REDCap is going to ask you, will this field ultimately contain protected health information? It's a simple yes or no question. So you go through, you're creating your database, indicate yes for the PHI fields. When it comes time to export your data, you have the option to remove those identifiers. So if you're handing your data off to someone who doesn't need that specific information, this allows an added layer of security. You can also scrub all free-form text. That seems to be a spot that identifying information can be hidden that's not necessarily obvious. And also, you can either remove all dates, which are considered protected health information, or you can shift every date by the same number of days under, I think, 365 days, 364 days, so that you can at least see time between certain events, but you're not getting the exact date that something is occurring. User rights management. So as the PI of a study, I have the ability to, I'm the only one who has the ability to add users to my study. And when I add users to my study, I get to decide what these users have access to. Which instruments do they have access to? Are they allowed to import data? Are they allowed to export data? Can they change values that have been entered previously? It's a very detailed matrix. It actually goes way across the page, but it really does give you full control over who can do what within your project. The audit trails feature, going back to the users management, I've given someone permission. Now I want to see what they've actually done within my database. So it goes down to the minute. You can see who has done something, what they've done, and when they've done it. In this instance, it's probably hard to see, but last week I exported many fields from the database, and it will list every single field that I exported, and it'll tell you to what file format that was. So in this case, I exported an entire database to Excel, and I did it at 2:02 p.m. It's just that added layer of traceability. So for each project in REDCap, there's a file repository. We tend to push this as a great place to store the final versions of documents. So you want the entire study team to be working from the same protocol, from the same informed consent, things of that nature, using the same logo for your project. Everything can be stored here related to that particular project. I mentioned the data quality reporting piece. If you want a sneak peek of any hiccups that you might be encountering once you hit the data analysis phase, you can run a data quality check at any point in time. You don't have to be finished. In this particular instance, there are 40 examples where the data set was missing values. So is that a matter of I forgot to go and key in certain values, or did I really not have the data for that? It at least gives you the opportunity to see, hey, you're missing data. Is it intentional? Is it not intentional? And in certain instances, can I fix it or can I not? So how do you learn about REDCap at Drexel? So I actually was sitting in the back sending an email asking if we could get a link on Drexel One, like Qualtrics, because that would be much more direct than our current process. Right now, all of the information is housed on the College of Medicine's research website. So you go to the research website, in the left side menu, we have a link dedicated exclusively to REDCap. And you can test drive the application before you ever commit. So this is a training instance. Please don't build a beautiful database there because it gets wiped every night. We've actually had people complain about doing that. Oh my gosh, I did so much work and it's gone. This is just for training. This is really just to get a feel if REDCap is right for your particular study. And then lower down the page, there's a REDCap SharePoint site, and that's where you go to fill out access information. Once you submit that request for access, you'll get an email for training in Blackboard Learn. There's a video that you have to watch. It's actually done by the REDCap Consortium. There's a Drexel-owned HIPAA refresher slide set, and then there's a 10-question quiz at the end of all of that. That is, it's easy, I promise. It's easy. So it used to be that I would go out and give these presentations, and this is the part where I would like hide behind the podium, because you used to have a College of Medicine username and password to access the system, and that is no longer the case. So you can use either your Drexel One username and password or your College of Medicine credentials if you have those. We're actually probably going to move long-term to just using Drexel One, so then we'll, hopefully make things even less complicated than they've been. But it's nice to be able to say that something's changed and it's changed for the better. So Drexel One will get you in. For those outside of Drexel, if you're collaborating with someone at another institution, they'll have to go through the university's non-employee associate process in order to get credentials to access the system. And it should be noted that you have to be on either the Drexel or College of Medicine network in order to access REDCap. So all of our questions around REDCap get funneled to the research.informatics@drexelmed.edu email address. We have a full team of people who man that account, and responses are very quick. So whether it's getting started with the application or you have a heavy-duty technical question once you're in there, this is where you go. Any questions?
This can be used for mobile data collection. Say
Yes,
you
it
have a team who uses iPads. So what happens if they have to collect data in a place and at a time when there is no internet connection? And could you elaborate a little more on what you said about having to be on the Drexel network? How does that actually work? Like you're working with people, like I'm gonna be doing an international study that's gonna have some of those characteristics that I just mentioned. Mobile, no internet access at times, people completely outside.
Right. So the first piece with being in an area that may not have reliable or any internet access, that's where the REDCap offline instance comes into play. So you would have a special instance of REDCap on your mobile device, whichever device that was, and you would collect data out in the field, and then when you hit a secure connection, your data would go into your REDCap database. So I think Dr. Lankenau has used this extensively with Children's Hospital of LA, I believe. But that's how you get around it. So you can have the exact same instrument that you see when you're connected to the internet out in the field. It's just going to save everything locally until you hit an internet connection, and then it'll go to your REDCap project. From a collaboration perspective, it comes down to that NEA process and how HR handles the NEA process. I know when we were handling things solely through the College of Medicine previously, the NEA process included access to VPN. You would have to indicate that someone would need VPN access when they got those new credentials to access REDCap. Getting into the weeds with the international piece, I would say you'd have to check with HR on how to do that, because I know sometimes they say that the social security number is a requirement, sometimes it's not, and in other countries you're not going to have a social security number. So that's really an HR call. We have had people do it successfully. It's just been kind of like a case by case. Is that helpful? Very much. Okay. Any other questions? Yes?
Are there any tools working with spatial data like geographic address?
I don't believe so at the moment, but I can go back and ask if anyone's seen any activity like that with the consortium.
Thanks so much, Lauren.
Thank you.
David, I'd like to welcome you up.
Hi, so I'm Jason. First thing I'm going to say is I'm going to reiterate what Larry and Paul said. Do your backups, please. Do your backups. Like, seriously. Yeah. So, and as a corollary, RAID is not a backup. RAID really offers redundancy in case of equipment failure, but if a brick falls on your laptop and the drive is completely smashed, that's where your backups come, or fire happens, something. So Proteus is our high performance computing cluster. We are sort of an oddball. Our accounts are not under Drexel One, so you apply directly and I grant your accounts. If you're faculty, it's basically a nominal procedure. I take the information because the Office of Research wants to keep track, and you get one. All right, so a bit about my background and how I fit into this high performance computing thing. I did my PhD with LIGO, the guys who got the Nobel Physics recently, and my postdoc at Brigham and Women's Hospital in radiation oncology. So my primary aim is to help you get your work done. And because this is complicated, that's where I come in. So what we offer about 120 servers with a lot of memory, a lot of compute capability, a lot of storage, 3 different kinds of storage, and I'll get to that. But it's like Formula One car. It's not just a stick shift like a car. There's a lot of stuff you have to do manually that you don't have to worry about on your desktop. Yeah, so we offer very fast connection because we have a large storage array. So you have large amounts of data. You want to make sure that all the computers in the cluster can get them quickly. So 162 terabytes of permanent persistent storage, 87 terabytes of fast parallel scratch storage. That's temporary storage you use when you're just running your jobs. And on each server, there's also 420 gigabytes of local scratch. The servers are a variety. Most of them are 84 of them are, actually, I'm sorry, 88 of them are 16 cores, 64 gigabytes of RAM. 16 of them are 64 cores, 256 gigabytes of RAM. So you have large data sets to crunch. This is where you can do it. And the clicker just went blank. There you go. Okay. All right. So it's the location is we are in Curtis Hall. It's attached to the main building. It's on the penthouse. It used to be the rifle range. Something missing to share. Anyway, but yeah, it's a secure location. Only a few people have access to it. You don't really need to go there because there's nothing you really can see. It's just a bunch of racks of equipment and air conditioning. So this is a schematic of what the cluster is. So campus backbone is a big cloud. There's a connection to the room that's 80 gigabits per second. It's compared to, say, Verizon Files is 100 megabits. So that's about 1,000 times faster. From there, each computer in the server room has a 10 gig Ethernet. You log into the servers. There are 2 login servers. That's how you interact with the system. And then all the compute nodes, the machines which actually do your work, are in racks there. 2 types of storage and administrative server. Everything's connected with a high-speed, low-latency network fabric. Because you have lots of data, and just normal Ethernet is going to be too slow if you want to read all that data. Yeah. So, like I said, we have a bunch of compute nodes here. By December, we should have GPU-enabled nodes coming on. Tech details, blah blah blah. Storage. Now, the storage here is, so, like I said, we're an oddball. There is no encryption because the emphasis here is on compute performance. So, and encryption is going to slow things down. So, if you do want to crunch PHI, you have to have it anonymized first. So, none of this is encrypted. Network. We're also part of the science DND. Well, Science DMZ is a sort of standard that is has fewer security restrictions because it serves to enable more research, facilitates research. So it's got a fast network connection to the outside world, blah, blah, blah. Less barriers for you to move stuff around. Theoretical performance. I don't know, so the typical laptop is 4 cores, and ours, most of them have 16, and some of them have 64. And the jobs you run, the kinds of jobs you run would be stuff that would make your laptop not usable at all while the jobs are running. This is software we have, MATLAB, Mathematica, those are site licenses. SCADA is under LeBeau, but we have had SPH faculty who were granted permission to use the LeBeau license for SCADA. Interesting open source stuff. We have R, we have Octave. Longtab has used R extensively. I think Jenny found Panther also. Maybe she used MATLAB. It's a bit unfriendly. Everything's running Linux. Everything's on the command line. So most of the time, you start using this when you are ready to do a lot of heavy crunching. You've started doing stuff on your laptop. You have your scripts, and you run on your laptop. It's like taking days to run. So what you do is you talk to me, and I help you set it up so you can run all of them. So our limits are generous. You can run for 48 hours at a time, and you can use 1,024 CPU cores at a time. Right? So that's what 256 laptops worth of computers at any simultaneously. You can do remote display of programs like MATLAB, Mathematica. So it's not all just command line, but it does require some additional software on your personal laptop. If you have a server, and it has to be a rack-mount server, you can host it in your CF server room. But talk to me, because there's a lot of technical details to work out for that kind of thing.
David, is there a reason why SAS isn't part of the software?
No one's asked.
Oh, okay.
If you need something, just ask, and I'll figure out how to get it done. So currently, there is no charge for using Proteus or even for co-location. There is no, well, with RCN coming in, we're about to impose a charge, but there is no timeline I know of. There are no firm numbers. The suggested sort of starting point for charge is $10 per CPU core month. So if you use your laptop full out 100% every day for 30 days, that's going to cost you $10. Just to get you a sense of the scale. And there will be subsidized accounts, of course. There's a link there if you want to look at usage from other researchers. As far as support, I'm in. We have on the books about 50 different research groups, of which maybe 20 are active in some degree or other. I know a lot, but I don't know everything. In particular, I don't know your area-specific stuff. I can usually figure out software, whether it's commercial or open source or whatever. So I've been doing this since I was in undergrad. 1989 was when I started doing computing in the service of research. If you have software you want, it has to be licensed properly. But again, all those are technical details, and you can figure it out when you talk to me. If you have software that's licensed only to your research group, we can do that as well. We have done that in the past. We can do custom installation if needed. If you have some area-specific software you need that's only distributed as source code, and you need it compiled, I can do that for you. And we also open it for use in coursework, but you should start the process one term early. Just email me and I'll get in touch with USJF board, and they can decide if they want to approve or not.
Now for Stata, I know there's different versions of Stata. There's a standard Stata SE, and then you go into Stata MP, and you have to buy based on number of cores that you intend to use. Which version is running on?
Offhand, I don't know. I mean, last person that used Stata, that was a few months ago, so I don't remember.
Okay.
It's whatever Labo has. I think it's MP.
But then they also break down like based on number of cores and.
Yeah. But yeah, I don't know details. I just
okay.
off the top of my head. So these are the dorm site faculty who have or are using Proteus. You might talk to them if you want to hear their experience using Proteus. And that's me. Any questions?
As far as performance gain, I know it's going to depend on the type of processing you're running, right?
Yeah.
If the job you're running doesn't do a lot of parallelization, then running out of cluster may not give you the performance gain that you expect. Right?
Yeah, but let's say even if your program itself is not parallelized, but what Lonnie Tao has done is she had 100 data sets, and so she ran 100 R jobs at a time.
Oh, okay, so it's just one simultaneous job.
Yeah. So even if your program itself is not parallelized, you can just run multiple copies all at once.
Now, running R doesn't require, because I think R doesn't have parallelization by default. But do you have to? There's another layer of coding required to run parallelization, right? Or not?
Yes and no. So R is the version of R we have is already multi-threaded.
Okay.
So we have what used to be called Revolution Analytics R, which is now Microsoft Revolution R. So it is multi-threaded.
Okay.
Okay, thanks so much, David.
Hello, thank you for hanging in there in this long 2 hours. My name is Deb Morley. I'm the Director of Data and Digital Stewardship at the Drexel University Libraries, and my colleague Kathleen Turner, who I think a lot of you already know.
Most of you are old friends.
Old friends. So we have been invited to be included to talk a bit about research data management support. Some of the areas we're going to focus on, we'll run through this fairly quickly, is the importance of data management, some of the support resources that are available to you here at Drexel, and talk a little bit about digital repositories for data sharing and data archiving, including ICPSR and some others. So before we sort of jump into it, I just wanted to, this is one of my favorite diagrams from the University of Virginia Libraries, where the data lifecycle is mapped out in a way that kind of parallels the research lifecycle. And I like this diagram because often we sort of get the questions of, why is the library involved in this? What are you talking about in terms of data storage? Isn't that what IT does? The whole notion of archiving, and archiving to an IT person is very different from archiving from an archivist or a library perspective. So in using this model, we talk about how even though the data lifecycle is sort of represented in this loop here, that you're thinking about your data management happens way up here. And as most of you know, many funding agencies, all of the federal funding agencies now require data management plans. Right? So NIH started in 2003, NSF, I think since 2010, since the White House Office of Science and Technology memo came out in 2013, requiring that federal funding agencies actually provide public access plans for accessing federally funded research output. There's just been so much more emphasis and requirement for that data management plan. That's the stick. I like to try to promote some of the carrot. Managing your data is a good idea. It helps you stay organized and all sorts of good reasons. But so this is where, one area that we're helping out with is at the front end. And then there's this sort of the implementation of your plan, doing what you said you're doing kind of throughout the research process. In here is where you're really doing your active management of data using resources like RedCap, OneDrive, and whatnot. And then it's not until you kind of come out to the end of the project that you're at that point of publishing. And not just publishing your article, but the notion of sharing your data, publishing your data. How do you curate that data, and where do you make it available to make good on those promises you committed to in your plan? So my colleagues did a great job of emphasizing this one. So one of the reasons for managing your research data is to minimize data loss. Also, it contributes to the reproducibility of your research, being able to actually have data sets and output available that's well described so that other researchers can not only potentially download and reuse your data, but understand what your research project was about. It contributes to that whole notion of open science. And also many journals are now requiring, they have a data policy. So in order to publish in that journal, you have to also either with that journal or demonstrate to that journal that you are publishing and sharing your data. And again, I mentioned the federal funding agencies, but also many of the funding agencies now have data management plan requirements. And then also, this is again the carrot, get credit for your research. Data sets are becoming a more citable research output, and through getting a persistent identifier, most of these repositories provide very well formatted citations that those who are then accessing and using your data can use and provide appropriate credit. So I want to thank all of you who participated in the faculty research survey that was conducted by the Data Stewardship Forum in the spring. I'll say a little bit more about that group a little later in the presentation. It was a survey on cyber infrastructure and research data management practices here at Drexel. And this is just one of the responses that to the questions about asking where do you archive your data. So we had close to 200 respondents at Drexel to the survey. So it's just really interesting to see the response to this. Clearly, the other was the big winner. And sadly, nobody's deposited to ICPSR. So you're going to hear us give a little rah-rah speech about the benefits of the ICPSR membership that the Office of Research so kindly funds for Drexel. So drilling down into that other, this were some of the responses, just so you can sort of get a flavor of what some of our colleagues are saying about where they're storing their data for in terms of long-term archiving and sharing. So why use a data repository? Depositing your data, and I think one of my colleagues clearly said that the OneDrive is really not the space for sort of that long-term archiving and preservation. So what a data repository will provide for you is maximizing access to the data. That's both in terms of making it more discoverable, because as part of this process of data curation, you're needing to assign metadata, description, again, that notion that if somebody was to access your data for reuse, that they would actually be able to understand if you're not available for some reason or down the line, that they could actually use your data to build upon or reproduce the research project that you also conducted. So also protect privacy and confidentiality. Kathleen, when she talks about ICPSR, we'll share a little bit about what they offer in this area. But again, it's a much more better option than, I had the opportunity with our Office of Research to look at some anonymized data management plans that were submitted by Drexel researchers. And, a number of individuals in terms of their data sharing are saying things like, well, I'll make it available on my public website, or I'll make it available when people ask. And I don't think those are sort of the answers that the NSF and the NIH are looking for in terms of, making things available. Number 3, again, providing appropriate attribution, having your data stored. Yes.
People are getting back at what they're supplying is inadequate. You have people come to you, companies saying, adverse feedback, and you need to revise, or are you just finding that by your standards, what's there is not really adequate, then stick back to the
So it's some of both, and I wouldn't necessarily say sort of my standards, but this is sort of in collaboration with our colleagues in the Office of Research. Yeah, but I would say it's all of the above in terms of just sort of our observation of what we're seeing, kind of looking randomly at those applications that get approved, those don't get approved, and talking with the agencies themselves and what they're seeing.
Present that nice flow chart of data management, from proposal conception to active work on data to repository to sharing and repository. You said that you're prepared to assist with that, but then pretty quickly you jump to repository and sharing. Is it true that really where you guys are set up to help us is with sharing and the repository function, and not so much that whole life cycle?
Well, again, there's the front end planning. And I would say at this point, and we're sort of building our chops in this area as well. And so,
is it really effective to spend a lot of resources planning, the data management during the active phase of research? I mean, really, your expertise is about the sharing, the archive. Isn't that correct? That's
right. But if you're familiar with the layout of the data management plan, and like the NSF plan is the 2-page plan is used somewhat as a model. Some of one of the important elements is around metadata description, and describing resources. The ability to discover resources is something that libraries have been doing for centuries, and so we can offer some recommendations, some thinking around. We don't claim to be deep subject expertise in this, and so it's more of a partnership. Sometimes it's a referral. So an example, we get questions about data use agreements. I've been contacted by an outside researcher who wants to use my data. What do I need to do? So, we collaborate with the Office of Compliance. I check in with Robert Asante. Do we,
So you think we should be, I'm sure that's your time. What I'm really concerned about is helping our researchers properly navigate the system. And when there's oftentimes the appearance of multiple front doors. And like one of them is like the door that has the Cadillac, and the other has the Maybe remember, let's make a deal and a deal.
Sure.
Thanks very much.
I remember it. Yeah.
So I can't quite. So I don't want to spend too much time on this, but that's a great example of if I had a data use agreement question, I would not think to go to you guys first. I would go directly to compliance or.
Which is great. You would hopefully get the same answer.
Okay, I guess this is for you. I guess I'm just not going to clearly see why you guys would want to be equally involved with metadata and anything about sharing and archiving. Nobody else does that. But but the other stuff, I sort of feel like I want to advise my investigators properly. I sort of feel like for all that other stuff, there are other resources that they should probably be using for that.
And I think that's great. And if part of what we can do is help to establish what are those best practices at Drexel, because that's the piece that seems to really be lacking. And I think, I don't think the library is trying to take ownership of this as much as helping to provide a coordinating role. It's part of what we do. We're sort of the intersection where a lot of disciplines come together. And maybe when I get to the end and mention the data stewardship forum, but no, I appreciate the feedback. Yeah.
Just piggyback quickly on that. So when we're preparing an app proposal, if we get to that section, data sharing and data management and sharing, can we work with you guys to sort of
yes,
draft a piece that
we won't write the plan for you, but we can advise on that. There's common language, we can help share, we can make suggestions. Yes,
That would be helpful.
yes.
What about the DMP tool that,
I'm almost there.
okay, great.
The preservation, sustainability, and then help you to comply with your DMP. So getting to the support of research data management, what can libraries assist with? So these are just 6 of the elements that are described within a data management plan and are some of the areas that, again, we can provide the consultation. And again, sometimes the consultation is really connecting you with a colleague in a different office. But again, providing that referral role. The library staff can help provide guidance on writing data management plans, and we do provide access to the DMP tool. It's a tool that has a series of templates for funding agencies. You can create logins, you can actually collaborate. There are multiple, and people from other institutions can share working on the same data management plan. And again, it's the idea of exploring options for data curation and data archiving to really answer that question. Is your data set complete and self-explanatory for users? We provide a service, we subscribe to a service called Easy ID, where we can mint or issue persistent identifiers for either a publication, or which could be a data set or a journal article. Just some examples. We provided an ARC for Andrew Cohen for his clone view, and the DOI for Jane Greenberg for a report that she published in actually in IDEA, Drexel's repository. So we can assist you with finding a data repository if it's not obvious to you, or if you're working in an interdisciplinary area and maybe not as familiar with some of the options are for repositories. We can assist with helping identify what some of the options might be. This is just an example of Drexel data that's deposited in Dryad. And then archiving data with ICPSR. So Kathleen's gonna share a little bit more with you specifically about the Inter-University Consortium for Political and Science Research, better known as ICPSR.
Okay. One thing that's important is that, of course, what we're talking about with archiving the data is after you've used REDCap or after you've used the resources within the university to work with your data to complete your project, it's when it's all done, when it's all wrapped up, then where does your data go? And ICPSR is one of the primary resources. I'm sure that most of you are very familiar with it. But one of the most important things about it is the scope of the data that it archives. It's currently containing data from 10 different countries. It goes well beyond the original conception of social and political science research. It's where data for things like the NHANES study and the maternal lifestyle study are stored. You could think of it as the main reason to put your data there is because that's where people go to look for data in, most health science, social science, an enormous range of disciplines and subject areas. And it's the added value that the ICPSR consortium provides that really makes it the key place to think about when you're looking for where to archive your data. The enhanced documentation of your data. I mean, it's not just your data, but it's all of the technical documentation of how to use it. Your data coding, all of the documentation that goes along with it. The physical security of your data across the years of changing technologies. I'm thinking back to when Paul and I first started working together 25 years ago, and the way technologies have changed since then. assessment of the confidentiality requirements, and tracking the usage, because more and more, we've always been accustomed to measuring, one of the measures of research productivity being citation of your publications. But, it's growing more and more that citation of your data has become an important indicator as well. And ICPSR does very well on providing tracking mechanisms for your data, as well as your actual publications. The protection of confidentiality is probably one of the key pieces of ICPSR. And because the focus of the repository was on social sciences data, there's a lot of attention paid to personally identifiable information. Part of their intake process for a data set is a rigorous review of any vulnerabilities of being able to identify individual respondents, not just looking at direct identifiers, obviously names and things like that, but also where there might be indirect connections that can be made between different variables that might make identification of individuals a vulnerability. And then they have varying levels of access that protect that. Well, first of all, they will actually go through and do some modification of the data if necessary and if possible to protect identifiers. Now, for a system like REDCap, that's in place before the data is exported, but data coming from other sources might not have that level of protection. Where necessary, where they can't completely modify the data, they have several levels of access in place that limit how the data can be accessed, either by signed access agreements, access only through specified servers. For the very, very highest level of protection, you actually have to travel to their site and access the data in physically secure encaves, Batcave, for data access. So they have that infrastructure in place that would be almost impossible to provide if you're, as people have said, providing data access on your own website or through some other mechanism. Just a quick picture of the complexity of their intake process. This is all the steps that your data goes through, from deposit to ingest to data management. And then they're actually working on processing your data on two different levels, because they're processing it both for secure archival long-term storage and to create a data package that's available for access and download and reuse. Because the whole purpose of ICPSR is not just to pack your data away in a vault somewhere, but to make it as accessible as possible to the research world in general, where appropriate. The model that they use, as it says there, is actually based on one developed by NASA. And finally, and as Deb said, this is sort of one of the carrots of storing your data in ICPSR, is that it is probably one of the most widely used repositories from which researchers access data. And they have systems in place to track that usage. How many times has your data been downloaded, and how many publications have been produced that cite your data. And Deb was just out there for their annual user meeting, and they talked about that they actually have a staff of librarians who maintain what they call their bibliography of data-related literature. So if you deposit your data with them and you go in and you look it up on their site, it will list for you all of the publications that are connected to your data. So Deb?
So just two other things I wanted to mention about ICPSR. So for the data curation services, there is a charge. I don't want that to be a surprise, right? Because folks didn't say it costs anything. Because we have membership, it's deeply discounted. Exactly what the charge is depends on a lot of different things, so it's hard to just sort of share a number. But we'd be happy to work with you or put you in touch directly with an individual ICPSR that can estimate that up front as part of your data management plan so that you can get that cost included in your application. Also, ICPSR recently started an open sort of version of their repository service called Open ICPSR. There is no charge at all, but there's also no curation on their part. But it is a place that you could upload your data set. They will assign a permanent identifier. So it could be sort of a quick and dirty way if you were going to publish an article and whoops, it turned out that the journal publisher requires that your data be accessible in some way in a repository. You could upload it through Open ICPSR, do the data curation yourself, maybe at a minimal level, or maybe you're confident in sort of doing that. Get the permanent DOI and have that available. You could then go back at a later time and see about maybe paying for services to have the data set more fully curated. The ICPSR, as Kathleen mentioned, I had the opportunity to go to it's actually a biannual members meeting. So Office of Research pays for the membership. Alistair has kindly asked the libraries to continue to be the steward in terms of sort of the outreach, the education, the awareness, the liaison for services. And so Kathleen and I are actually your representatives now, starting this year. And so at the meeting, the new executive director had to brag a little bit and said, you know that computer virus that hit Equifax, it also hit us. We discovered it in less than 30 minutes, quarantined it, eradicated it, and lost no data. So ICPSR is one of only about 8 repositories within the world that have reached this certification of being a trusted digital repository. So not to overemphasize it as a resource, but I think we're very fortunate to have membership with it. So I just wanted to, in closing, mention the Data Stewardship Forum. It is the group that provided, that facilitated the survey last year. It's a group of administrative heads who all feel that they have a stake in research data. And I think that part of the challenge that we have here at Drexel is feeling within those departments that we tend to be a bit siloed. And so the forum has come together to really help think about putting together best practices. The forum has been reviewing Drexel policies. There's about 8 of them that specifically mention data output in terms of research and how the policies fit together. And these are the offices that are currently part of it. Ali from CCI kind of represents the ADRs on this group. And I think that the question asked about sort of the library's role and whatnot was a great one. I think, in reflecting on that, the thing that's so key about the data management plan is everything sort of trickles downhill from that. So if the plan doesn't exist or it's not a well thought through plan, by the time you sort of get to that end part, things start to fall apart. And I was more deeply involved with sort of the data curation aspects of research data management in my role at MIT for about 4 years. And there were maybe like 25% of the projects that would come to us that were so unwieldy and so undocumented and so kind of not thought through that the actual archiving became almost impossible, or it was done in a way that, what we felt was very unsatisfactory in terms of making that data findable, accessible, interoperable, and reproducible, FAIR, which is sort of the acronym that the Research Data Alliance is kind of putting out there to plant in everyone's mind. So thank you again for being here and for including us in this important topic. Questions for Kathleen and I? Yeah.
When you mentioned about the fee for curation, is that something you sort of, it's like a one-time fee for the curation?
It is a one-time
services?
fee.
But
Yeah.
once it's been curated, you don't have to.
That's
pay for it
right.
to be
That's right.
there.
And they will, and it's preserved, ongoing. So, yes. Yeah.
How much of the work they do for you? How much you as a PI have to supply them with? I know this is a very broad question.
Yeah. Yeah.
But I'm trying to think, is that something you need to plan to devote a lot of time to actually make your data set available?
Well, I think this goes back to the question of sort of best practices and sort of guidelines. And ICPSR offers a lot of guidelines on their website and training materials. And, there are certain areas that if you have an interest in learning more, we could potentially, kind of partner and do like another workshop of what are the things you should be thinking about up front to minimize sort of the headaches of, gee, my variables were red, green, blue, yellow. Like, what does that mean now that I'm way down here? That's an oversimplification. But what are the key elements to be thinking about up front so that by the time you get to that point, the curation is fairly straightforward. Ideally, it would be possibly even just a handoff to them and them assigning the ID.
Again, their infrastructure is so highly developed that they have, pages and pages of documentation and flow charts of
and
what you need to do to process your data.
Because we are a member, we sort of our phone calls, we sort of click in there and you can directly, talk with them and ask these questions. So, you don't have to come through us. Yeah.
And that's a really good point. I think that suggests how curation step may the need for curation may require you to do other things all along. I can imagine they with that in mind. I don't know whether or not at that level of detail it's going to bubble up with the things that you need to integrate data management plan going in, but it is something that you probably need to start paying attention to earlier than just, okay, study's done, I gotta stick this data someplace. That's just my sense.
Yeah. Things like file naming conventions, things that, for some people just are so obvious, like of course you need to sort of have this all along. When I first got involved with this work at MIT, I was a little intimidated to talk with researchers about this, but, in terms of, the truth of the matter is, a lot of the people we talked with were the graduate students because a lot of this work is falling on their shoulders to manage the data. And that was another question on our survey. And it was like very few out of the 200 PIs or 200 researchers who answered our survey, very few PIs claimed that they are the ones doing the data management. It's most times it's the graduate students, it's IT people in some cases, which is a little surprising.
And then of course that grad student leaves.
Yeah. Well, and we're very involved again. Our role as sort of educators. So the library's been participating in the responsible conduct of research course, and we were invited last year to be involved in the session around data ethics, and we're bringing in the data management piece, and that's the course that's required by NIH and really kind of all the government funding agencies if you're doing research. So we're trying to reach that graduate student population as well.
Thank you.
Thank
very
you.
much.
Yep.
Thank you.
Oh, and we have some cards in the back. It's just sort of like a little promo thing of kind of our services and email address. But you feel free to reach out to Kathleen and I directly if you have questions. So thank you.
Thank you.
And thanks everyone for hanging in. It was a bit of a long session and a lot of information that was shared, but hopefully you found it useful and you're leaving better informed than when you were when you came. So again, the slides and the presentation will be available. So please let your colleagues know how useful it was and that we will make this information available to them as well.